Hello folks, welcome to CodeCrucks. In this video, we will discuss an example of minimizing the DFA. To understand this example clearly, I recommend you to go through my previous video in which I have explained the equivalent states or the concept of distinguishable state. The link of that video is given in description box. In that slide, I have also explained the algorithm for performing minimization of the DFA. Consider this is the DFA having 8 states and we would like to minimize this DFA. Let us compute the transition table for this. If we look at this DFA carefully, then state Q3 is unreachable. It means if we start from initial state Q0, there is no way to go to the state Q3. So it is increasing complexity of DFA without adding any power, and hence we can skip that particular state from the computation. So we will delete it and our transition table will look like this now. As per the algorithm, we will start from partition P0. So we have to divide all the set of states into two sets. States which are non-final state, that we will put it into one set in one group, and states which are final states, that we will put it into another group. So Q2 is the only state and which is the final state, so reduction is not possible, but there are chances that some of the states in that red group might be identical or might be equivalent. So we will check whether or which states are equivalent, so we can club them and we can minimize the DFA. So we will compute now P1 or the one equivalent. So we will read one character at a time from all the states and we will see which states are distinguishable. So if any states are distinguishable, we will put them into different groups. So we will split this red group into multiple groups. For that, we have to read all the input alphabets from Q0 to Q7 states except Q2 because it is already in different group. So Q0, 0 goes to Q1 and Q01 it goes to Q5. Similarly, we have to compute it for Q1 state and Q4, Q5, Q6 and Q7. If we look at this carefully, we can realize that state Q0, Q4 and Q6 exhibit same characteristics. It means their output belongs to group 1 only. So they are non-distinguishable states. So we will put these three states into one group. If we look at the state Q1 and Q7, they are also producing the same output. So on input 0, they goes to the red set, and on input 1, they goes to the blue set, right? I have color coded for the better understanding. So Q1 and Q7 are also non-distinguishable. So we will put them into one separate group, and state Q5 on reading 0 it goes to group 2, and on input 1 it goes to group 1. So that is also distinguishable. So this red set of 0 equivalent, now we will divide into three sets. One set will have states Q0, Q4 and Q6. Another set will have states Q1 and Q7, and the third group will have state Q5 only. So this is the division of distinguishable states. We have to repeat this procedure for Q0, Q4, Q6 because they fall in one group and they might be distinguishable, they might be equivalent. And the same process we have to repeat for Q1 and Q7 as well. So let's now find out partition P2 or the two equivalent of this state. So we'll compute the output of Q0, Q4, Q6 on input 0 and 1. So delta Q00 is Q1, which is the purple set, and delta Q01 is Q5, which belongs to green set. Next, Q40 goes to purple set and delta Q41 goes to green set. So these two states are definitely non-distinguishable. They are identical so far. And if we consider Q6, then it goes to the red set only. That means Q0, Q4 are equivalent and Q6 is different. So Q6 is distinguishable from Q0, Q4. So we will split that red group into two further subgroups. In one subgroup we will keep Q0, Q4. and in another subgroup we will keep Q6. Fine. Now we will process Q1 and Q7. They may or may not be distinguishable when we'll check for the two equivalent. So now we will read 0 from Q1. So one is going to red set, and on another input it goes to the blue set. If we check for Q7 state, then we are getting the same output, okay? That it goes to red set on input 0 and it goes to blue set or blue group on input 1. So Q1 and Q7 are not distinguishable. It means they are identical. Only the red set will be split down and it looks like this now. Q0, Q4 are non-distinguishable, so we are putting together. Q6 is different, so we'll put it into separate group. Q1, Q7 are not distinguishable, so they are identical. We will keep it into the we will keep it as it is. Fine. Now we have to make a check for Q0, Q4 whether they are identical or not, they are equivalent or not. So we will generate P3 out of this. That is 3 equivalent we have to check. Let us read 0 and 1 from Q0. So on reading 0 we are staying on purple, and on reading 1 we are moving to green. If on reading Q4 we are getting the same color code or output belongs to same set, then we will say Q0 and Q4 are equivalent. So let us find out whether they are equivalent or not. Yes, they are equivalent. So P3 will remain as it is P2. As Pk is same as Pk minus 1, we will stop here, and this is the final set of states. So Q0, Q4 will be combined into single state. Either we can put it into single state or we can rename it as we saw in previous two videos. Similarly, Q1, Q7 we can put it into the single step. We can merge it into single single state, or we can rename it as a B. Right? And we will draw the final state transition diagram. So on left we have original DFA which is having 8 states, and on right hand side as we can see that Q0, Q4 are merged and Q1, Q7 are merged, and we have only 5 states into this DFA. So this is the minimized version of the original DFA. Power of both DFA are same. So whatever language is generated by DFA on left hand side, the same language will be accepted by the DFA on right hand side, but with less number of states. So DFA on right hand side would be faster to simulate compared to on the left hand side. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.